All right, so here we are in lesson 4, and in lesson 4 we are focusing on rectangles and rhombuses. You can say rhombi or you can say rhombuses, either one will work. We're looking at properties of shapes. So we're going to start with constructing a rhombus, and we have to talk about the properties of rhombus. And as you can see here, opposite sides are parallel and 4 sides are equal. All right, so parallelogram has 2 pairs of opposite parallel sides. Trapezoid has 1 pair of opposite parallel sides. A rhombus has 4 opposite parallel sides, right? So 2 pairs and 4 sides that are equal length. So we're going to start out by drawing one. Get your paper, get your ruler, get your straight edge, get ready. If you don't have all of those things, go ahead and get them now. You're also going to need a protractor before long, so you can pause the video and get one of those as well. Okay, let's get into our drawing. You're going to draw an angle that's not a straight angle. So any angle you can draw on your paper, and it makes sense to make it sitting up, something like this, right? Because that's going to be part of our shape. Okay, so draw an angle that is not a straight angle. Use your ruler to mark points on the rays of the angle that are the same distance from your end point, because it has to have the same size sides, right? Because it's going to have 4 equal sides. So you're going to measure, I'm going to measure 10 centimeters up, and I'm just going to mark it with a point. Okay, you could do that too. All right, and then label the vertex of the angle as B and the points on your ray as A and C. Okay, so we have our angle is B and our points are A and C. These are the 3 points that are going to be the vertices. Remember, a vertex is a corner. So let's write vertex, and the plural of vertex, more than one vertices, right? Those are just corners, okay? We're going to use a straight edge and a right angle tool, which is your index card, to draw a line that is parallel to one of the sides of the angle, making sure it passes through the point marked on the other ray. Okay, so it's going to be parallel to my line that has the A on it right there, but it's going to pass through my C over here. So I'm going to make sure it's parallel. It has to be the same distance from that line. And okay, just a line going up the same distance and the same angle. And then repeat on the other side of the angle, using my straight edge to make this as close to a perfect rhombus as I can. And I'm going to label my last vertex D. And I'm going to label my parallel sides with angle marks. Okay, so I have 2 sides that are definitely parallel. I'm not sure about the other 2. You might have a square, and you might have just 2 sides that are parallel. And then we're going to measure the sides and the angles and write the measurement on the inside of the construction. Okay, so let me show you, just because it's a little hard to show you on my little piece of paper. Let me show you. It should be about right here. Okay, there is a rhombus, right? So we have opposite sides parallel. Yes. And opposite sides parallel. Yeah, so what was I talking about? We have definitely these 2 opposite sides are both parallel. So I have 1 set of arrows and 2 sets of arrows, just like the one on the screen, but mine isn't tilted as much. Mine is a little more straight. And then we're going to use our protractor to measure those inside angles, okay? And if you have questions about how to use a protractor, please stop the video and ask, show me how to use a protractor, okay? All right, so we have those measured. And in the previous lesson, some of the parallelograms we made had four sides with the same length and others didn't. But we were just talking about parallelograms then, right? Today, all the parallelograms that we made have four sides that have the same length. So when can a parallelogram also be a rhombus? A parallelogram is also a rhombus when all four sides have the same length. And you can see it on the screen there, 3 inches, 3 inches, 3 inches. They all have the same length. So this is a parallelogram, but the more specific name is rhombus. Are rhombuses parallelograms? Yes, because they have two pairs of parallel sides. If rhombuses are classified as parallelograms, is it true that all rhombuses, is it true for all rhombuses that their opposite sides are parallel and their opposite sides have the same measure? Yes, because parallelograms have two pairs of opposite sides that are parallel, and rhombuses are parallelograms, and these properties are true for all parallelograms, right? So their opposite angles have the same measure. Do you notice that? 119 and 119, 61 and 61, right? The opposite angles, the ones that are across from each other, right? What makes a rhombus different from other parallelograms? Four sides have the same length, okay? So get that in your head. A rhombus, four sides the same length. Parallelogram, opposite sides parallel. Okay, now we're going to cut out our parallelograms and we're going to fold them and find some lines of symmetry. Okay, so cutting things out is the fastest way to show lines of symmetry because they can fold directly on top of each other, right? Okay. So try to fold it in half. Doesn't quite fit. Okay. Try to find some lines of symmetry. And what you might notice is that the two diagonals of your rhombus, diagonals, are the lines that go from vertex B to vertex D. And let me get a different color. From vertex A to vertex C. That is cutting it completely in half. And hopefully that worked with yours and your cutout too. But you can see it here as well if I take this and fold it over. And in a minute, we're going to use the Symmetry Explorer Digital Interactive to try that out a little bit more. So the diagonals of a rhombus are probably lines of symmetry, but let's just double check it, right? Let me get rid of this. And I'm going to open this, and this is just going to take a minute to jump to 16. Sorry about that on the screen. I told it to clear itself. Okay, and remember, lines of symmetry are going to cut it into two equal halves. And let's jump to 16 here. There's some examples of some lines of symmetry right there in our fluency. All right, so let's start by making a rhombus. Now remember, a rhombus, okay, there's a square, and a square is a rhombus because it has equal sides and the opposite sides are parallel. Now let's try the diagonal. Look at that. It folded right in half, right? And let's try the other diagonal. I guess I could reset it, huh? Okay, let's try another kind of rhombus. So we need to have equal sides, but it doesn't have to have right angles, right? So let's try something like that. Okay, and then let's put it in the diagonal, and it's going to fold straight in half, right? Pretty close, and maybe I didn't have it exactly perfect. All right, let's reset that one. And let's try making it a little bit smaller. That's the only problem. Sometimes it gets a little. Okay. Opposite sides need to be parallel. It's about a rectangle there. Oh, not a rhombus, right? Not a rhombus because equal opposite sides are not equal. And you can see two lines there. The opposite sides are equal, but not all four of them, right? Okay, so let's try something like, oh, I don't think that one moves. Now I need opposite sides to be equal, so let's make it a little bit smaller. Okay, how about that? I'm not sure all four sides are equal, though. It's a little challenging just to use this thing. Let's see. Yeah, not quite opposite sides equal, but hopefully you got the idea, right? I'm not sure if I can, take the time to make everything perfect. Okay, we'll try one more time. Close, but not quite there yet. Okay, so the diagonal is the line of symmetry for a rhombus. So is this a property of all rhombuses? Yes. And all rhombuses have two diagonals. Let's at least get a good one on there for you. We know we can do a square. There, we have all sides equal. There you go. Pretty close. Not exactly perfect, but we're going to have to accept not having perfection all the time, right? Okay, so does this statement, all rhombuses have at least two lines of symmetry, does that describe a property of rhombuses? Yes, because it is true of all rhombuses. Okay, do the diagonals in your rhombus intersect at their midpoints? Okay, so let's, if I drew another diagonal here, you can see how it meets in the middle, right? In the middle of this one and in the middle of that one. So they intersect at their midpoint, right? Okay. Are diagonals of a rhombus perpendicular? Do they meet at a 90-degree angle? Yes, they do. Okay, so we have a lot of properties of a rhombus, and we'll talk more about those in the next video. I have kind of a different video for you. See what you think of this one. I thought you might like it.
A long time ago, about 2,300 years ago to be a little more precise, there lived a man in ancient Greece called Euclid. Now, he looked nothing like this drawing, really. This is just my idea of how he looked. Over 1,000 years after he died, someone else thought he might have looked like this, but I prefer the way that I draw him. He looks more like an ancient Greek. Euclid wrote the first great book on mathematics and geometry. It must have been a really good book because they were still using it every day in schools well into the 20th century. Now, all the best ideas are simple and brilliant, and Euclid had a really simple and brilliant idea. He thought he would explain stuff from the very beginning by finding something very simple that everyone could agree with, and then he would build on that simple idea. He decided that a simple point, a fixed position in space, was a good place to start. You can think of a point as if it were an X on a map that shows where the treasure has been buried. Euclid explained this to his friends.
Okay, so we'll learn more about Euclid and geometry in the next video. Thanks for watching.